Okay. So, a couple of things that was flagged to have a look at. I think it was flagged to do one of the questions. So, do you want to read it out, or do you want to flip it around there so I can see it? It was the last one on the page, is it?
3.
Yeah. Okay. So, differentiate and simplify. I'm explicitly telling you to simplify. Probably switch to that. Okay. Y. Well, it doesn't actually say y. So, x sine x plus 9 over log 8x plus 4. Yeah? Oh, what the heck? It's all connected here, isn't it? Oh no, this cable's a bit dodgy, isn't it? You have to give it a... Come on. Don't let me down. Oh, Angela, can you tell her what page?
144. 144.
What is going on with this? Let's see if I do a switcheroo. Come on. Apologies. Let's see. Oh, come on. Whoa. Abort. Okay. We have action. All right. Goodness sake, don't touch anything. So steady. Okay, let me just close down these extra windows I don't need anymore. Yeah, so I need that one, so let me close this one. Come on. Alright, I guess I'll have 2 notepads today. Okay, so what rule do we need first? Quotient rule. So I feel like I'll need a lot of space, so I'm just going to write a big old fraction here. Right, the bottom squared. The bottom times the derivative of the top. And that requires the product rule. So that would be 1 sine x plus 9 plus x. And now I need the chain rule. So the derivative of sine is cos, and the derivative of x plus 9? Derivative of x plus 9?
X plus 9.
1. Minus the top times the derivative of the bottom. Now I need the chain rule again. Yeah?
Yeah.
So the derivative of log is 1 over x. So that's 1 over 8x plus 4. And then multiplied by the inside derivative of 8x plus 4? 8. Now, I want to simplify this a bit. Okay? I don't like the fraction here. I can cancel everything by 4 here. Is there anything else I can do? Not much, really. The only way I can see of simplifying this is cancelling out the 4's here and then multiplying the top and the bottom by 2x plus 1. Because 4 goes into 8 twice, 4 goes into 8 twice, 4 goes into 4 once. And then I'll multiply by 2x plus 1. So that'll be 2x plus 1 times log 8x plus 4 times sine x plus 9 plus x cos x plus 9 minus 2x sine x plus 9 minus 2x sine x plus 9 over 2x plus 1 times log 8x plus 4 squared.
Where'd you get the 2x?
That 2x
Yeah.
was this
That's
2 I just put in the front.
Students, I still have this thing. I thought that you could only multiply by something if there was an equality sign.
No, you're free to multiply the top and bottom of a fraction by anything except 0. No need to have an equality sign. Now, while you're writing that down, let me find a binomial example here. Binomial hypothesis test,
That's
yeah.
it. We're done.
Oh, in
This
this
one.
question.
Yeah. Well, I can't, unless somebody can see something else I can do to actually simplify this. Like, there's not much point in multiplying this out,
Mm,
because you're just going to expand things.
yeah.
I mean, you could, I suppose, group this sign with this sign, but to group that sign with that sign, you'd have to expand this. So you'd be in the same situation as before. You would have two things grouped together and one thing outside. The only difference would be you'd have the sign grouped together and the cos and the log on the outside now. It doesn't actually reduce it by anything.
Yeah.
There's no need to... There's nothing, I can't see anything you could do to simplify this.
It would be better. It would be like if you separate it, like the 2x all the way to the negative on its own minus this over the, and then so you can divide the first fraction because you can take out 2x plus 1, 2x plus 1.
Yeah, but we put the 2x plus 1 in on purpose to cancel this fraction. So we would...
You separate it like separate it.
Oh, I see. But is that really simplifying? Because now you've got a bigger expression. You know, so you've written the denominator twice now. So I really can't see any meaningful simplification to do next. Let's see. Yeah.
Sorry, because this, if you separate it, that would be 1 over then 8x plus 4, and I feel like that's a bit lower.
No, because you have to. All you're doing is taking one thing and splitting it into two. You're doing the opposite of simplifying. You're making it needlessly bigger. Yeah. Let's see. Okay. Let us find. We want to do some more hypothesis testing. Let's have a look. I'll find an example online here. What's the biggest value of the n in your binomial tables? It goes up to 30, doesn't it?
Yeah.
Is 30 the biggest?
Yeah.
Yeah, 30 is the biggest. Okay. Can we scroll down?
Yeah.
Have you done any interesting case studies or any interesting examples with column? No, you don't. With column, nothing. Nothing interesting. No interesting experiment.
That would take more than 1 hour to go through. So. No.
Okay. I need to find something interesting. What are you doing in biology at the moment?
Menstrual cycle.
What's that?
Menstrual cycle.
Oh, that's not interesting. Right. What else have we got?
Still reproductive system.
We're not started the genetics thing yet.
Not done genetics. That would have been nice actually,
Yeah.
because you have some things you can test in genetics.
Yeah.
Have you done any genetics?
Not really. No. We're not started.
Nothing.
They've just done the codons thing.
Oh, the thing I've used that example already, haven't
Yeah.
I? What is GU? Let's see.
GU.
Smokers at GU. Oh, that must be some. No, okay. We'll just make up. We'll just make up an example. So let's say we what do we want to do? We want to test if. What could we test? Some new. What? Give me an idea. I'm drawing a blank here.
Drug for cystic fibrosis.
Say again.
Drug for cystic fibrosis.
Some drug. Ah, we've done one like that. Give me something juicy, something interesting.
Chemo.
chemo. Nah.
Surgery.
You see, the example I'm looking at is examples I already did. So an employer claims to be an equal opportunity policy. We did the, remember we did the sexist example already. Let's see what else we've got.
We can test the hypothesis that we're going to get it.
That's actually a prediction rather than a hypothesis, so we need to test something like studying pays off or something like that. Oh, I don't want to do another stupid example with like seeds or...
Is this all been recorded?
Yeah.
Maybe what color kittens a cat could have. I know it's genetics, but still.
Oh, so boring. Fine, okay, alright, fine.
The kittens?
Fine.
No.
We'll do the kittens or something, right? So we have a sample. No, I'm not doing the kittens. That's so stupid. No, we'll go with a sample of 30 participants.
Monkeys.
Fine, okay. A sample of 30. Sample of 30 rats. We'll keep it scientific. We'll say a sample of 30 rats. Now, there is a type of rat that's used in experiments for treatment of, for drug treatments and things like this. So there's this particular breed of rat that they use for these experiments because it has a very high chance of developing cancer. I can't remember what breed of rat it is, but it's basically a rat. Oh, come on, get off the phone, listen. Yeah. No, it's okay, it's okay. You can search it after the example if you like. There's a particular breed of rat in biology that they use for drug treatments to test cancer drugs. And this breed of rat, it develops cancer after, I think after 6 weeks. So it's very prone to developing cancer. Maybe it's something like, we could say 25% chance that the rat will develop cancer after 6 weeks. So it's a sample of 30 rats of breed. Now I don't know what the breed really is, so I'll just call it C for cancer. And what's unique about these rats is that 25% of them will, on average, get some kind of tumour. Now, there is a guy in Italy. I don't know if Colin has told you about this guy in Italy. Has he mentioned any doctor in Italy to you? No, okay. Well, he's a jerk, firstly, because what he does is he releases, the politest way I can put this is, he releases questionable studies trying to link genetically modified food with cancer. So what he did was, in his study, he took 30 of these rats, he fed them the genetic food, and he said, oh, look, the rats got cancer. Like, yeah, but the rats were going to get cancer anyways because you're using the cancer rats. So the question is, did enough rats get cancer so that you could think that there was some increase in the cancer rate? So let's say he fed the rats, fed them GMO food, and let's say, I don't know, I'll make up an example. Let's say fed them GMO food and 10 rats got cancer. Now, you could say there was an increase in cancer rate among rats that were fed GMO food. But of course you realise that's not quite right, because the number could have just fluctuated naturally. Because it's not like it's going to be exactly 25%. After all, 25% of 30 is what? What's 25% of 30?
5.
Guys, wakey, what's 25% of 30? I'm giving you a simple question.
80.
Stop looking at me like I'm the most beautiful person in the world and tell me what 25% of 30 is.
7 point something.
Oh my goodness, if you just look at me guessing, I'll come down there and slap you. Would you actually calculate it? Do you have a calculator? 7.5. Okay.
Trying to be natural.
What?
Trying to be natural.
Thank you for your being honest and true to yourself. So it's not like you can get 7.5 rats developing cancer anyways, right? So the question is, has there been enough rats getting cancer to indicate that GMO foods causes an increased rate of cancer, right? We think not, but let's test it formally. So, what is the null hypothesis here?
They got it 25%, like naturally.
Yeah, so could you give me a sentence?
GMO.
Ahmed, are you on your phone? Would you get off your phone?
GMO food did not have an effect.
Yeah, well, give me a sentence.
Well,
No, like you give it in the way we usually state this.
25% naturally got cancer.
Ah, no. The null hypothesis is that the probability a rat will get cancer is still 25%.
Yes. Sorry.
Yeah?
Yeah.
Okay, let's not complicate our lives. And what's the alternative hypothesis?
More than 25%.
Yes. That the P is more than 25%. Now you see, remember I said when we did this a week ago, this question is answered poorly on the exam, but it's not particularly difficult. So if you're still answering this poorly, it means you haven't practiced enough of them. Okay, so that is the hypothesis and the null hypothesis. Now we want to calculate the p-value. So, how many rats got cancer? 10 of them. So we want the probability of getting the observation that we got or more extreme.
Yeah.
So if 10 rats got cancer, what would be more extreme?
More than 10.
More than 10 got cancer. So the p-value is the probability of 10 cancer cases or more. Right? However, what is the problem here? We can't look up or more in the table book, can we?
Yeah.
So we have to look up the opposite. So what's the opposite here? 1 minus probability
Of 9.
9 or less. That's 1 minus, and then we have to go to the table book. N is 30. P is 0.25. And X is 9. Okay, so look this up and give me 1 minus this number.
0.1966.
The final number.
0.1966.
0.1966. Yeah?
Yeah.
Right. So, do we reject or do we not reject the null hypothesis?
We do not.
OMG. Okay, I'm getting very concerned now. Do not reject the null hypothesis. Do not reject it. Because this
Greater
is
than 0.
more than
0.
the 5%.
Yeah.
So we do not reject the null hypothesis at the 5% level. So if we do not reject the null hypothesis, that means we have evidence that the null hypothesis is still possibly true. The null hypothesis being that the cancer rate is still 25% among the rats. Therefore, the GMO food has not increased it. Now, we can't say that for certain. It's possible that the GMO food has increased the cancer rate, but we weren't able to detect it because it was such a small increase. We could not, for example, detect going from 25 to 26%, because in order to do that, we would need at least 100 rats, because we're looking at a 1% change. Okay? So, it's wrong to say we accept the null hypothesis. We're simply saying we do not reject it. We haven't got evidence to reject it.
Okay.
Okay, this is a very subtle difference. I am going to open up a past paper to see if we can do a hypothesis test. So please write this one down. Let's have a look at an actual past paper. What reason is it to be angry? No comment.
Exactly.
No, I don't say exactly now.
He's being polite.
Yeah, that's all I'm being. What version did we look at last time when we did the... Oh, so there's only 2 versions here, so let's have a look at version 2. I can't switch because of the projector, so I can read it to you.
Can you summarize it and do
Yeah.
like this guy? Version 2, which year?
It's version 2 of the most recent paper. Now, I'll read it out to you. Can you all listen carefully? I'll read the story. Listen carefully. In a college, 45% of students catch a cold each winter. So that means 45% of them get sick each winter. During 1 year, a special food is offered to students, which, it is claimed, reduces the risk of catching the winter cold. So you can see where this is going, right? At the end of the winter, a random sample of 20 students who had taken this food was selected, and it was found that 5 of these students had caught a cold. So 20 students took this new food and 5 of them got the cold. What percentage is that, 5 out of 20? That's 25%.
Yeah,
How many people did we say normally get the cold?
45.
So it seems like what? At first impressions, it seems like what?
The food is working.
The food is working. It seems like it. However, it was only a sample of 20. So maybe this group of 20 was just a little bit healthier by chance. Okay? So for 2 marks, I want everyone to do this. State your hypotheses, both the null and the alternative. If you need me to repeat any information, I can. State your 2 hypotheses.
Can you repeat what you said after a special food is offered to students?
I'll just read everything again to be easier, okay? In a college, 45% of students catch a cold each winter. During 1 year, a special food is offered to students which, it is claimed, reduces the risk of catching a winter cold. At the end of the winter, a random sample of 20 students had taken this food, was selected, and it was found that 5 of these students had caught a cold. Okay. No, it should only take you a few seconds to write this down.
Okay.
What's the null hypothesis here? Could you just poke Mubarak to wake him up? Are you dozing off there? Maybe you're too warm. We'll take your jacket off.
Probability 0.4.
What is the null hypothesis?
0.0. Probability 0.4.
P equals 0.45. Now think very carefully. What's the alternative hypothesis? Ooh, not quite. Not quite. Less than 0.45. Because you're claiming that the food is an improvement, not that it makes a difference. That's an improvement. Yeah. So, okay. You got that? Yeah? Is that okay?
Yes.
For 2 marks? Mubarak, either participate or I'll eject you from the class. This is not sleepy, sleepy, sleep time. Okay? Do you want to take out some pen and paper? Because I'm asking everyone to do something for me. You haven't done this part. I want you to do the next part as well. Carry out a suitable hypothesis test at the 5% level. What is your conclusion? Okay. I want you to test this hypothesis now at the 5% level, the usual 5% level. What do you need?
Formula book.
Well, do as much as you can until you have to actually look up the formula book, and then I can. Yeah, but then if you get to like that, then there's only one step left.
Yeah.
Yeah. So
Yeah, but I need the value from the table.
yeah, no, I know. So what I'll do is I'll open it, and you can ask me what to look up. So you just let me know when you're ready, okay? So do you see what I meant when I told you in the exam they make it a little bit easier for you because you notice the p is already less than 0.5. Okay, you should be wrapping this one up. So, the p-value is the probability of observing what you observed or more extreme.
Yeah.
How many people did we observe getting a cold?
5.
5. So that's the probability of, so it's 5, now is it 5 or more or 5 or less?
Yes.
5 or less, very good, 5 or less. So that's actually a straightforward,
Yeah.
direct table book value where the n is 20, the p is 0.45, and the x is 5. And I have the table here. I did have it. Where the heck did it go? Oh, here it is. 20, 0.45, and what am I looking up? 5. That comes in at 0.0553, which is more than 5%. So what does that mean?
You do not reject.
Yeah, do not reject the null hypothesis at the 5% level. Yeah.
There's something I don't understand
Yeah.
about all of this. What exactly do you mean by saying at the 5%?
Yeah, the 5% is not like a rule, it's just a convention. So it's not like there's some maths rule that says you reject when it's more than 5, or you reject when it's less than 5, and do not reject when it's more than 5. That's just a convention. And the reason the 5% is chosen is it means that there is a 5% chance you are wrongly rejecting the null hypothesis. So if somebody did a trial, and the result of the trial was to reject the null hypothesis, so let's imagine in this case instead we got 0.049, then we will reject the null hypothesis. Okay. That doesn't mean we're right. We might have wrongly rejected. Maybe the food actually does do nothing. There's a 5% chance of that happening. So that actually means that 1 in 20 papers, automatically, 1 in 20 papers published will incorrectly reject the null hypothesis. This is why it's important to reproduce and replicate trials. Because by definition you will be wrong 5% of the time. But it means you'll be right 95% of the time. So this is the balance. Well, roughly. Okay. You got that one? Yeah. So in total, look at everything we wrote on the screen. How many marks do you think is on the screen right now?
5, 4.
6. Right? So it was
1, 2.
1, 1, 1. How else did they give you the 6? 1 mark for saying 5 or less. 1 mark for actually getting the answer here. So have I got 6 yet?
No, 5.
Oh, and then 1 mark for comparing it to 5%. There we go, that's the 6. 1, 2, 3, 4, 5, 6, yeah.
Section A question.
Section B question, you know, and there's, if I look here, this part for 6 marks was a hypothesis test with binomial. Now sometimes they also have hypothesis test with chi-squared, and I can see in version 2 of the paper.
You said this was version 2.
Yeah, I can see in version 2 of this paper I'm looking at, they don't. I think in version 1 we did last time, it had a chi-squared, didn't it? It was some, what the heck was it? Something about coloured. We did a chi-squared exam question. We did. I'm certain of it.
Maybe you did it with HSL.
Are you sure? Because if I did, I can do it with you guys now.
Yeah, we didn't.
Does anyone remember doing a chi-squared exam question with me where it had like a ratio of 1, 2, 3 to 4?
No.
Oh, wonderful. We'll do it now. So I'll look, I think it was in version 1. Version 1. That's fine, Angela, that's fine. We'll look at it now. Version 1. Version 1D, 6D of the most recent paper. Red, white, purple. Okay, okay, good. We'll do this one. So again, listen carefully, please. I'll read the information to you. A sack holds a large number of bulbs of different colour. Bulbs are the large seeds that are used for flowers. The label on the sack claims that the number of red, white, purple and yellow, so red, white, purple and yellow, are in the ratio of 1 to 2 to 3 to 4. That's the claim. And you have selected 100 bulbs. And from your selection, you got the following: red, white, purple, yellow. So you selected 8 red. Now before I continue, if I picked out 8 red, and if they really are in the ratio of 1, 2, 3, 4, how many whites should I get? I should get 16. So the fact that I got 23 first gives me a little bit of suspicion, right? How many purples should I get? 24 if you compare it with this, or a different number with that. You actually get 33. And yellow is 36. Now, these guys look quite similar, and they really shouldn't be. And this guy should be twice as big as that, and it's not, and so on. So I kind of think that it's probably going to end up being a rejection. Right? So the first, well, guess what the first thing they ask you to do is?
No.
State the null and alternative hypothesis. And guess how many marks that is?
2.
2. Okay, so give me that, please. State the null and alternative. Mubarak, have you stated the null and the alternative? Right, what's the null hypothesis?
Red is 0.1.
Yeah, go on.
And white is 0.2, and purple is 0.3, and yellow is 0.4.
Yes, that's one way to state it, and I would accept that. It's a very long way to state it, but you're correct.
Yeah, I wrote each of them.
You wrote each of them. Fine, that's fine.
So for one,
So, there's a couple of ways to write it. The way he wrote it is interesting and it works. You said the probability of getting a red is 0.1, the probability of getting a white is 0.2, and so on. That works fine. Okay. Did anyone state a different way? Did you state it? No? Mubarak? Was that a word? Is that a yes or a no?
Can we just put the ratio in?
Yeah. You could. The simplest thing to do is just say the ratio red to white to purple to yellow actually is in 1 to 2 to 3 to 4. Okay, but what you said is fine as well.
Display the hypothesis as a ratio. Instead
Yeah,
of,
for this one you can, yeah. And the alternative?
It's not.
Just not 1 to 2 to 3 to 4.
Oh, and like, can we do
No. Okay? Yeah. So, the next thing, what do you think the next thing they'll ask you to do?
Calculate.
Yeah, well, they actually break it up to make it a little easier for you. So, yeah, but even before the chi-squared, they ask you to calculate.
Observed minus expected.
Even before that, just calculate the expected. So remember that this table represents the observed values, but they want you to calculate the expected values now. So you'll need to draw another table, and you need to write down how many you expect of each. And remember, I'll remind you that you have 100 bulbs in total, and you expected to get them in the ratio of 1 to 2 to 3 to 4.
10, 20, 30, 40.
Yeah, yeah. Yeah. So you were expecting 10, 20, 30, 40. Because how much does this add up to? 100. And what's the ratio here? It is 10 to 20 to 30 to 40, which is the same as 1 to 2 to 3 to 4.
Yeah.
Okay. And so what do you think the final part is? Test. Now they're being a bit weird here. They said test at the 10% level, which means you only you reject when it's less than 10%. I don't know why they did that, but anyways, I want you now to test and see if see your conclusion, please. Get the Mubarak, are you working? You have an answer? You have an answer? Do you need the table book or you're still confused?
I'm not sure.
Yeah. No, he doesn't need the table book. That's not his problem.
Yeah.
You're confused. Answer? Answer? Who actually has an answer? One.
I'm not really sure how to approach it.
Now you see. Do you remember in class I said this is answered poorly in the exam? Even though it's actually not that difficult. At least I don't think so. You just need to practice. So, remember the formula for chi-squared. It's in the formula book. It's the difference between the expected and the observed
Over
squared over the expected. Right, so the first one. What's the difference between 8 and 10?
2,
Squared
4,
over
10.
the expected, which is 10. The difference between 23 and 20? 3 squared over 20. The difference between 33 and 30?
9,
3 squared, 9 over
30.
30. And the difference between 36 and 40? 4 squared, 16
over 40.
over 40. And what does that equal?
1.55.
1.55.
Yeah.
Okay? Yeah?
Yeah.
Okay. Now, who remembers how many degrees of freedom does this table have? You remember, yeah? Yeah, did you first say 4 and then realised it's 3, yeah. So, what we do, we go to the table book and we look up what the critical value is, and if we go to 10% and 3, we get a critical value of 6.25. Now, 1.55 is less than 6.25. So, is it rejected or not? No, it's not too critical. It's not too big. So we do not reject the null hypothesis.
Huh?
We do not reject it.
Didn't they say to test
Yeah.
at 10% level?
Yeah, did I
It's
not look
le-
up 10%? I did.
Yeah,
I
but
looked up
it's-
10% and 3 degrees of freedom and I got 6.25.
Yeah, it's less.
Yeah. Now you see, this is where you have to be careful.
Okay.
In the previous test, the p-value, if it's less than 5%, we reject.
Yeah.
Okay. What's different in this test is you're not actually calculating the p-value. There's no way to calculate the probability here. It's too difficult for you to do. Instead, what you're doing is you're looking up what's called the critical value. If your chi-squared is too big, so the critical value is 6.25. If you're over here, the chances of that happening is quite small, less than 5%, or in this case, less than 10%. So this is where a p-value is less than 10% in this case.
Okay.
You can't actually calculate the p-value. All you can do is look up a number in the table book, 6.25. And the meaning is, if your chi-squared is more than 6.25, this is unlikely big. How unlikely? Less than 10%.
Okay.
That's why it's the opposite way here. So here we do not reject. I know it's easy to mix it up. That's why you have to practice.
Okay.
Did you have it backwards?
Yeah.
Yeah, we see, that's why we're practicing. So the marking scheme, how did it break down? Let's have a look here. I'll give you the marks now. The heck? 17, 18.
It's for at least 6 months.
Yeah, because the previous one was 6, wasn't it?
This one has an extra question.
Yeah, so I'll tell you now. What number did I say this was? 6B or something?
6D.
D, right. Okay, please look. The marks were 1 mark for stating this. 1 mark for stating this. 1 mark for getting this. 1 mark for stating this, and then using your calculator, 1 mark for getting 1.55. 1 mark for looking up and getting 6.25 in the formula book. So this is where Angela and others lose a mark. Well, no, actually, you would have stated this,
Yeah.
but you would have lost your mark here because you have it the wrong way around. Here. 1, 2, 3, 4, 5, 6, 7, 8 marks. Remember, 8 marks, I think, is like 8%. I think it's a 100-mark exam. Maybe it's not.
Sir, can you explain the degrees of freedom again?
Yeah, the degrees of freedom.
Yeah,
So, Barak, what are you doing? I'm still teaching here. Take your stuff back out. I'm literally in the middle of explaining this question. Right, so the degrees of freedom. What was the degrees of freedom here?
3.
3. Now, the reason for 3. So the way the degrees of freedom work is this. Imagine you reproduce this experiment, okay? You are another researcher and you redid this experiment. But you kept the overall information, the overall constraints the same. So perhaps Angela did this experiment with 100 bulbs and she gets her result. And me being a good researcher, I know I have to repeat what she did. So I have to do the same thing she did. So I too have to take 100 bulbs. In how many ways could my observations change? Well, could I have gotten a different number of reds here?
Yes.
Yeah. A different number of whites?
Yes.
A different number of purples?
Yes.
Yes. It's true, I could have also got a different number of yellows. But by the time I get to this number, it's already fixed because the total must be and can only be 100.
Yeah.
So only 3 of these can actually vary, and the 4th one is constrained. So the degrees of freedom here is 3. There are 3 parameters, 3 quantities that can vary. The 4th one isn't a genuine variable because it's constrained. The total has to be 100. Yeah?
Yeah.
So that's how the degrees of freedom work. Why it's 3. Okay. That's okay?
Yeah.
Yeah. Now look, I'm telling you. You practice these, they're not so bad. You get pretty good marks for them. Okay, you can get 8 marks doing this, or you can get 8 marks doing, let me see, what else you could do for 8 marks.
I think probability is one of the
Yes.
easiest way to score.
Hey, you're 7 minutes early.
Now?
So 12:53 by this clock.
Oh, so I was aiming for 12:50.
Oh, okay, alright. You can wait 30 to 60 seconds?
I can wait even more.
Yeah.
90 to 95.
Oh, wonderful. Okay. So, as I was saying, you can get an easy 8 marks by doing a chi-squared, but unless you practice them, you're not going to do them. And the fact that most people here didn't successfully do this example means you're not practicing them. Okay? The alternative, you could get, for 6 marks, you could calculate the correlation, but that's quite time consuming. What else could you do? For 5 marks, you could use the quotient rule and find the turning points.
Lovely.
Yes. You could, what else could you get? Right, here's an excellent example. We haven't done this yet, but you can tell me if you think it would be easy or hard to do. Right? You could do that for 5 marks. See what point I'm making here? Yeah, the hypothesis testing is a good question, but students screw it up because they don't practice it, because they don't get their head around it. So please, for goodness sake, practice the hypothesis testing. Okay? Alright. Who am I missing here? The groups haven't split yet, have they, Colin? Which group is this? One sec.
I just do.
HS2.
What was the formula for chi-squared again?
It's in the formula book.
Observed minus expected over expected.
Which one? This is HS2. Michelle? Abir? Autumn? No. Celine? Sophia? Mubarak? Shadira? Mohamed? Sabrina? Moza? Angela?
Yes.
Ahmed? Safra? Neil?
No.
So I'm missing Michelle, Sabrina, Moza and Neil. Right. Off you go.
Sir, can we do goodness of fit next time?
Can we do what now?
Goodness of fit.
This is goodness of fit. Chi-squared is also called goodness of fit.
Is it?
Yeah.
Ah, no wonder I was so confused. couldn't find chi-squared in my book.